Okay, so this here would be the the 12th lesson in statistics, and we're going to start looking at probability. Before we start probability, the concept of sample space is important to know about. And the objective of the lesson is to identify the sample space for simple experiments. So what I want to do is I want to define what a sample space is, first of all. Before I do that, I need to define something called an experiment. An experiment is a process that leads to an outcome, right? So a simple probability experiment is any activity or process that you can produce distinct outcomes from. Okay? For example, if a coin is flipped, the result is either going to be a heads or a tails, right? And in the case of a sample space, the sample space is the complete list of every possible result that can occur from the simple experiment of tossing a coin in the air, which side it's going to land on. Now, if we only have one coin, the complete sample space is just heads and tails. If we change the experiment a little bit, like we toss two coins or roll a dice, the sample space starts growing. So in this lesson, what you will learn about is how to clearly identify and list the outcomes that experiment could possibly have, so that when you solve future probability problems, you would have this tool to work with. Let's start off with a coin, right? And let's see how the sample space would expand when we increase the number of coins, right? So with a single coin, it has only two possible outcomes. We have a heads and a tails. So the sample space is just going to be head tail, sorry, not head. When it comes to two coins, the sample space increases, and now we have every possible combination of those two coins being tossed. And those combinations is 4 combinations now, and we can consider each coin flip or each flip of the coin as a separate event. So we can have the first coin landing on heads, which is why we have an H here and a H here. And then the second coin can either land on heads or tails, which is H or T. And if the first coin land on tails, it could have tails, tails, and it can have two options for the second coin, which is having a head or a tail, right? So we have two coins, one coin, two coin, and this is the first option, the second option, the third option, and the fourth option. Those are the options that can happen when you flip those two coins. You can see that the sample space starts growing. Depending on the number of coins, in this case n, you'll have 2 to the power of n outcomes, and you can work that out to see how many outcomes you can have for probably 6 coins flipping. Okay? The next one that we have is a dice. Now, a single dice has 6 possible outcomes, so the sample space is as follows. You're going to have 1, 2, 3, 4, 5, 6. And if it is that we have how many ever dice, it's going to be 6 to the power of n outcomes. So if we have 2 dice, it's 6 to the power of 2, which is 36 outcomes. And if you have 3 and so on, you'll be able to calculate how many outcomes you're expected to have. Now, I'm giving you the formulas on calculating the outcomes for these situations, so that if it is that there's ever a situation where you need to count a reasonably large number of outcomes, you can just use the formula and get the large number of outcomes. You'll see why when we start calculating probabilities. Now, a deck of playing cards provides a slightly more complex sample space. There are 4 suits. You're going to have suits of, let me just put the pen here. You're going to have the suits of your hearts. You're going to have spades, and I can draw these things well. You're going to have your diamonds, and then you're going to have your clubs, right? Yeah, these don't look at all like what you're going to find on the deck, but you'll get the idea, right? Right. So each suit has 13 ranks. You'll have your ace, you have 2 to 10, you have a jack, a king, sorry, queen comes next, and then a king, for a total of 13 ranks, right? If we draw any one card, a single draw can be one of any 52, and you can see this 4 ranks times 13 suits, and you will see 13 times 4, 40, 12, 52, right? We're not including jokers and anything else, right? We're just those 4 ranks and those 13 suits. Sorry, there's 4 suits and 13 ranks. Sorry. We just flip that around. Suits, ranks, right? So you have those 4 suits and those 13 ranks, right? So if we draw one card, we can draw something like, say, King of Hearts. It's going to have a K, and it's going to have a heart symbol on it, right? If you understand the structure, then doing any kind of probability calculations with playing cards should be easy as well. I make sure I say about this playing cards because I realize some students don't some students have never met a deck of cards. Let's continue from there, right? As long as you understand the structure, doing probability calculations would not be a problem, right? So you have 1, 2, 3, 4 suits, and those suits go from ace 2 to 10, jack, queen, king, right? For a total of 13 ranks, right? I repeat that several times, but yeah. All right, so contingency tables, right? Before you learn to apply coins and dice and whatever card examples, you need to understand what a contingency table is, because it's one of the tools that we use to list probability space, right? It consists of rows and columns that would tend to represent different possible values of an experiment. And if you systematically fill it in, you would be able to visually confirm the list of outcomes. That's one. And two, you would not miss any of the outcomes. And the method is very easy to follow. Let's say we look at a two coins, right? 2 coins. We have coin 1 going in this direction and coin 2 going in this direction. And then all we do is we just simply combine the positions of each of those, and we will get the outcomes, right? I'm just going to change the pen here so you can see what I'm saying, right? So if it is that I want this one here, here, this one here, here, right? So you can see right away that these cells inside of here are the combination of rows and, is a combination of the columns that come from here, right? And a combination of the rows that go across here. Let's look at another one, which is for 2 dice. So we have rows, which shows the 6 outcome of your first dice. And then you have columns that show the 6 outcomes of another dice. And each one of these cells is just simply the possible combination. So you can see how we get 36 possible options. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 36. Okay. So for 2 dice, the contingency tables is 6 rows, 6 columns, each cell showing the unique pair for the numbers. And it makes it clear that you have 36 outcomes, right? Now, such a table is extremely helpful when we start analyzing events and we have to sum things such as what equals 7, or both dice showing the same thing. We can see that both dice shows the same right along the diagonal here, right? And then we can see where both dice add to 7. Look at this one. Here, this is 7, 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 right? It's very easy to spot what combinations give you a certain amount. Okay, now that you know how to calculate, now that you know how to draw these contingency tables, you can try something with the deck of cards, right? You can try something with the deck of cards to see how you get your 52 opportunities, your 52 cards. So you'll have your suits going across and your ranks going down, and you'll be able to see how your 52 is. If you want, I can start you off. You'd have your heart, your spade, your diamond, your club, and then you have your ranks going down. So this is suit, rank, ace, 2, 3, and so on. You'll have like ace of hearts here, and your ace of spades here, and so on. Right. Sorry. Right, so that's it for today. And we explore the concept of a sample space, and you know how to look at how it applies, you know how to apply it to coins and dice, right? So the clear takeaway is list all the possible outcomes of the experiment. Sorry, I can't easily mute my mic. Right, so once you have your outcomes, you can be able to list them in contingency tables, and this is what we will be using to calculate probabilities in the next lesson. I'll see you in the next lesson.